Welcome everyone. In this video we will solve the question that you see on the board right now, which is a question from the 2017 PAT, the Physics Admissions Test. Now let's read the question first ourselves together, and then if you want you can pause the video, try it on your own, and then when you're ready you can continue with the video. So it says a parachutist jumps out of a plane at height h. She is subject to air resistance with a force of negative alpha v squared. The equation of her motion is given by the equation that you see, and it asks us what are the units of alpha. Then we can solve the rest of the question. So the first thing that I want to mention here is, even if we weren't given this equation, we would be able to derive it, because it is simply using Newton's second law. It is using the fact that the net force equals mass times acceleration. We know that mass times acceleration is mass times the time derivative of the velocity, and the net force is simply the sum, the vector sum of all the forces acting on the object. So that's where the equation comes. And notice that whoever wrote the question, they chose downwards as positive, as we can understand from the sign of mg. Because if it was negative, g would be negative, we would use negative g, and mg would be negative mg, not positive mg. So they chose downwards as positive and upwards as negative. Now this isn't that important in the question, and even I think for the third part, if you're calculating the energy, I wouldn't choose it like this. Now by choosing it like this, you can of course do it. The directions that you choose don't matter as long as you're consistent with them, but I just want to use the convention that they assigned because it doesn't matter for this question. So it says, what are units of alpha? Well, we know that the force of drag, the air resistance, is alpha v squared, and by putting the absolute values, I highlight that I am interested in the magnitude. This means that alpha is equal to the magnitude of the drag force divided by velocity squared. Now, if I take the unit of all the quantities, and I do that by putting these brackets around, let's see the unit of alpha. So what is the unit of drag? Well, it is a force, so it is a unit of Newton. Now we have that the unit of velocity is meters per second. We square that to get meters squared per second squared, which is second squared over meters squared times Newton. We know that force is equal to mass times acceleration. The net force is equal to that. So the Newton in SI units is going to be kilograms times meters per second squared. We realize second squares cancel, m's simplify. We have kilograms per meter as the unit of alpha, which is just a constant. So we are done with the first part of the question. Now for the second part, we're asked to calculate the terminal velocity of the parachutist. The terminal velocity is the velocity that the parachutist reaches after a certain time, and that velocity is conserved throughout the motion. The velocity doesn't change from that point on, because as the velocity increases, the drag force increases as well, and at some point it will be equal to the gravitational pull. And when that happens, the net force is equal to 0. So there is no acceleration, which keeps the velocity constant. And that constant velocity, we call it the terminal velocity, which is going to be which will come from this equation. And notice I put a subscript t to denote that this is not an ordinary velocity. This is the terminal velocity. And if I solve for the terminal velocity, then it is going to be mg over alpha under the square root. So we are done with the second question as well. Now moving on to the third part. It says, estimate how much work is done by the air resistance as she falls, assuming that she is falling at near terminal velocity by the time she reaches the ground. So let me draw it here. This is going to be the point initial point is h, and I choose the ground as 0. I choose upwards as positive. As I said, it doesn't matter for the energy calculation. If we were asked to do something else, I would suggest that we would stick to the direction choice of the question. This is the initial point, and it will move like this. It will be falling downward with a velocity of v terminal at the end, at the final. So I will say that the work done by non-conservative forces is equal to the work done by the drag force, because drag force is the only non-conservative force in this in this problem. The gravitational pull, it is a conservative force. And this is going to be equal to the change in the energy. The change in the energy is equal to the final energy minus the initial energy. And so what is the final energy? There is only kinetic energy, which is going to be 1 over 2 m vt squared minus the initial energy, which is only gravitational. It is mgh. Here I want to substitute for the terminal velocity. I will substitute this. So we get 1 over 2 m mg over alpha minus mgh. Moving on, we're going to have, if I factor out mg, we will have m over 2 alpha, I believe, yes, minus h is the, well, is the terminal velocity, not the terminal velocity, excuse me, I'm sorry, is the work done by the drag force. Now, this is going to be negative because the energy decreased. So, and I'm not sure what the question meant. Maybe they're asking for the positive, the negative. The actual work done is this. It is this. But if they want the magnitude of the work, which I don't know if that's what they want, you just multiply by -1 basically. And I want to mention one thing here. We're done, but I want to give a little insight here. So since this is negative, this means that m over 2 alpha minus h is also negative. So m over 2 alpha is less than h. And what does this mean? Does it mean that, let's say that alpha has to have a certain value? Well, no. It simply means that if the particle, not the particle, if the parachutist, oh, I'm really making mistakes today. If the parachutist is to reach the terminal velocity by the time they reach the ground, their height, their initial height, should at least be m divided by 2 alpha. Otherwise, by the time they reach the ground, their velocity will not be their terminal velocity. Not yet. Okay? I hope this makes sense. But anyways, this is it for this video. If you have any questions, please add them in the comment section. I hope to see you in another video. Until then, take care.